So I'm going to do the wrap up for the mass and inertia stations thinking sheet 1. And I'm going to just talk through several of the things that I asked you to do on this thinking sheet. So the first thing was that you looked at a YouTube video where people were playing around with a bed of nails. And first thing they did is they wanted to show you this was an actual bed of nails. And so they dropped a grapefruit on the bed of nails, and it was not pretty. The grapefruit got skewered. And so these were actual nails on the nail board. So then they put a person on the nail board and then put a nail board on top of him. And then on top of that, put a concrete block and hit him pretty hard with a sledgehammer. And so the idea was, well, the person's kind of like grapefruit, he's going to get skewered. But did he? Nope, he emerged without a scratch. And the question is why? And the answer is because the block has a whole lot more inertia than the grapefruit. And so inertia actually protected him. So let's talk about how that happened. So the block is really massive, which means it has a lot of inertia. And inertia is resistance to change in motion. So the block was initially stationary. It wasn't moving either vertically or horizontally. And so when you hit the block, even when you hit it with a sledgehammer, the tendency was to not move. And so the block actually didn't move. It broke into pieces. So if the block were not there and you hit the board with a sledgehammer, the person would feel it. Again, it probably wouldn't pierce him a whole lot, but he would definitely feel it because the board has a whole lot less inertia than the cement or the cinder block. So inertia is a real phenomenon. It's a characteristic of matter, and you see it in real life, not just in staged tricks or in cartoons. So remember, another thing I had you watch was cartoon physics with Wile E. Coyote, and he ran off the cliff and then paused in the air and then realized he was in the air and then fell. That actually is an exaggeration of inertia, but it really does happen. So remember, I had you watch this real life video of a bunch of dry leaves on a trampoline, and a person jumped through the leaves and made the trampoline go down, and the leaves just kind of stayed suspended there. Now, they didn't actually stay suspended because the video recording was in very slow motion, but because leaves are made of mass, their tendency is to not move. And so when the trampoline was taken out from below them, the initial thing was not move, or they have a resistance to a change in motion. So stationary was their motion, and they had a resistance to start moving. Now, with just our eyes, we would have seen the leaves move instantly, but in slow motion, you can actually capture inertia, and it is a real phenomenon. Okay, so another thing that I had you think about or do was the air pucks, and you were playing with the air pucks in the hallway, and you could not start it into motion without touching it. Or if it was moving, you could not make it move in a curved path without touching it. If you got it to move in a curved path, I'm sure that you touched it. You could not get it to change speed without touching it, and touching it with your feet is still touching it. So the idea is that the puck is either stationary and it stays stationary unless you touch it, or it's moving in a straight line and it continues moving in a straight line unless you touch it. So the definition of inertia, or one definition that you can have, is the tendency of an object to resist changing its motion. Okay, so that's what inertia is. So question, it's a thing, so how do we measure it? And the answer is you cannot measure it. It's a property of matter, and it's never been directly measured. Think about it. What are the units of inertia? It doesn't have units. So you mean we've spent 4 class periods on something that is not measurable and it has no units? Have I been wasting your time with imaginary physics or fake physics? And the answer is no. In our experience, objects with a lot of mass tend to resist a change in motion more than objects with a little bit of mass. So mass is often considered a measure of inertia. But if you talk to people who really know what they're talking about, and commonly people will say mass is a measure of inertia, but it's really not. Mass and inertia are not the same thing, and mass is not a measure of inertia. So it's not like one mass unit is equal to one inertia unit. We do not know this correlation, but you can safely say that an object with more mass has more inertia. Sorry, that's covered up with my picture. An object with more mass has more inertia. So you can say that, even though, strictly speaking, mass is not a measure of inertia. Okay, relationship between mass and inertia. Yes, there is a relationship. More massive objects have more inertia. And as far as we know, this is always true, but physicists are really detailed and precision-oriented, and so they leave open the possibility that this is not true. But in general, we will say that more mass equals more inertia. So for example, an elephant has more inertia than a human, which means it's harder to change an elephant's motion than a human's motion. Okay, so that's the relationship between mass and inertia. Okay, what about the relationship between mass and weight? Okay, mass and weight are 2 completely different things that can be situationally related. Okay, 2 completely different things that can be situationally related. So the mass of an object depends on, 1, the type of particle. Okay, not all particles have the same mass. For example, lead particles are more massive than hydrogen particles. So they are very similar in size, but lead particles are a lot more massive than hydrogen particles. And if you remember some periodic table trends, as you go across periods, objects actually get more massive and smaller. Yes, more massive and smaller. So the mass of an object depends on the type of particles that make up the object. And then the second thing that mass depends on, and this one is a no-brainer, is that the number of particles, as they increase, then you have more mass. And it doesn't matter what type of particle you have, more particles means more mass. And I'm talking like the same particles. So if I take styrofoam and I add more styrofoam to it, it always gets more massive. Or if I take water and I add more water to it, it always gets more massive. Okay, so adding particles of the same kind to an object, literally adding any particles to an object, will make it more massive because all particles have mass. Okay, the weight of an object depends on, it does depend on the mass of an object, but here's where the situational issue comes in. It also depends on the strength of a gravitational field. So gravitational fields are what you find around really massive objects, like planets, okay? If there is no gravitational field, then there is no weight. So weight is the force of gravity on a mass. You're going to have to learn it at some point. You might as well learn it now. Weight is a force. Okay. I cannot emphasize this enough. Weight is a force. Now, I know in chemistry you weigh things in kilograms, but that's actually incorrect. And people are fooling you, and they're trying to make you learn bad science when they say weigh the object on a scale. And you will almost always hear me say mass an object, but even then, it's kind of problematic, which we will not go into. But really important to know, weight is the force of gravity on a mass. Weight is a force. Learn it now. You will not regret it. All right, so we have the question, how do you know if an object has a lot of mass? How do you answer this? Well, you probably want to go back to the basic definition when you're trying to answer this. So, an object with a lot of mass is something that I would not want to kick because I'm going to hurt my foot. Okay, so if I try to kick something really massive, like a big stone, okay, it would hurt my foot if I kicked it, or I tried to set it in motion. Because remember, things with a lot of mass have a lot of inertia, which means they resist the tendency to change their motion. And so if I went to kick a big rock, that would hurt my foot. Okay. Or set it in motion, that would hurt my foot. So another way I can tell if something has a lot of mass would be I would not want to be in front of it if it were moving towards me because I would be changing its motion or stopping it. Okay. So the way we can tell something has a lot of mass is just by going back to the definition. Would I want to be hit by it, or would I want to try to start it in motion? And if the answer to either one of those is no, then it probably has a lot of mass. So then, would this answer be true anywhere in the universe? Anywhere in the universe, if I kick something really massive, would it hurt my foot? And I think so. Okay, I'm pretty sure. The jury is I'm still leaving room for maybe not, but I'm pretty sure if I try to kick a really massive object in space and start it in motion, I'm pretty confident it would hurt me a lot. Or if a really massive object is hurtling towards me in space, I'm pretty sure it would hurt me when it ran into me. So